So inside of that folder, so in that new CamInstructor Lathe folder, let's make another folder and call it Lesson 1. Then inside the Lesson 1 folder, we'll save our file, first initial last name, Lesson 1, lecture part. And then I'll hit save. Once you save the file, if you hit Alt-A, you should be able to make sure your autosave's turned on and going to do what it's supposed to do. That way, as we create these 4 toolpaths we're going to create today, it'll save them for us. I always say, and I'll repeat this later, but I always say the lathe is easier to program. It's more of a pain in the butt to set up. Okay, which is why we don't tear the lathe down very often. We'll talk about that more as we get into this. We like to leave standard turning tools, parting tools, threading tools, things that you use regularly on the lathe, we like to leave in the lathe, not taking them in and out of the turret, because it is kind of a time-consuming process comparatively to the mill setting it up. So, it's all okay here. All right, go to your planes. Okay. Now, notice next to like where we normally go to create new planes, there's this little icon that says Select Lathe Plane. Now, if you hit the drop down there, you see there's basically 4 options. Now, it's all about which type of lathe you have, which side your turret on, which side your spindle on. Because you could have a spindle, a right side spindle with the turret on the front, okay, to where in that case you'd be doing everything in negative negative. Well, our turret's on the back side, spindle on the left, so our Z's positive, our X is positive going towards it, so we're positive positive. So the other thing is there, when you're looking at that, you notice it's D plus Z plus, and then down here you got X plus Z plus. So those are the 2 planes we can use. The difference between those, and it's just for creating the geometry. That's what this is for, to make it easier as you create a lathe geometry. We've got a part here that has diameter dimensions. Okay, so what we can do is, if you click on the D plus Z plus, that will activate that plane down here, and then you can click right here and make that your active plane for the construction. Okay, now you can make it, you could just make it fully your active plane if you want for now. But before we toolpath, we will go back to the top plane. Okay, because the top plane is going to be what our toolpaths are going to work out of through the machine definition. Okay, so this is just for drawing the part and making it easier on yourself. If you didn't do anything, if you just left it in top plane and you drew the part, you could still draw the part. You just have to remember that you're drawing all radiuses, which would be the same thing if you went to the X plus Z plus plane. Okay, so this basically, if you look down here in your right corner, it sets it up to where you're getting Z's as for the length, just like the lathe. You know, left and right on the lathe is your Z axis, up and down is your X axis, or your diameter adjustments. Okay. All right, everybody get the D plus Z plus active? All right, let's go to our levels. Let's just make level 1 our part profile. The lathe, typically the geometry is usually a lot simpler too, especially for just turning stuff. Live tooling parts, you know, obviously you're going to have more geometry going on. That's down the road, but for just standard 2-axis turning, all we have to draw here is the upper profile of the part, the top half. Okay, so the first thing I'm going to do is I'm going to go to wireframe and go to line endpoints here. And I'm going to draw a line from the origin right down the middle here, straight to the left. And I'm going to make that the length of the part, which is 2 inches. Okay. All right. So the next line, I'm going to draw the line straight from this endpoint right here, straight up. Now what I want you to do though, don't click or anything, leave it live. If you did click on the 2 here so you can reselect this second endpoint. And I want you to hit the space bar. Okay. The first number that you enter is your diameter number, your D. So there, instead of putting in like 1.45 divided by 2, just type in 1.45, comma, and you want the endpoint of it to be at -2 in Z. So you're putting 1.45, comma, -2, and then hit enter. Okay. What? Alright, so basically what that means is we can enter stuff as we go here. So now, this next line here, I'm drawing straight this direction. So I'm just going to hit the space bar. My diameter is not changing, is it? So I'm just going to put a comma with nothing in front of it. That means it's keeping the same diameter value because there's nothing in front of that comma. I know that comma is hard to see, guys. Try to zoom in. Put a comma there. And then I'm going to type in -1.5 for the Z. And I'll hit enter. I'm going to draw straight down from here. Just going to hit the space bar again. And this time, I'm going to tell it we're going down to 1 inch for the diameter. The Z is not changing, so I'm just going to put comma and not put anything after that. Ooh, why didn't it keep it? There we go. Just type the 1 without a comma. We all good to there? Okay. Then the next one, we're drawing straight from here over to the origin. So I'll hit my space bar. I'll tell it staying at 1 inch, comma. We're going to Z0, 1, comma 0. I'll hit enter, and that'll finish out my boundary. And the last part of it, I'll just connect the dots. Now, guys, a lot of times I get that next question is, couldn't we just draw it and divide them by 2? Yeah, you could. You could draw that whatever way is easiest for you. I just want to show you that there's another way to do it too. Okay, a lot of times I'll show you something up here, but then I'll be right around the corner and tell you this isn't how I do it. But this is another way you could do it if this makes more sense to you. Okay, sometimes people like to be able to plug in those diameter values, rather than have to make sure they divide them all by 2. I typically type in the diameter /2 and let the Mastercam do all the math for me. So like when I draw this part, if this was me, I probably wouldn't even mess with the planes. I draw my line here, I'd hit my length 2. I draw my line here, I'd hit my length 1.45 divided by 2. My line here, length 0.5. Now coming down right here, my length is going to be the 1.45 minus 1 divided by 2. And I'll draw my line here, 1.5, and I'll connect my dots. So it's whatever's easiest for you. Okay, at the end of the day, I think I've said it a lot. I don't care how you get to the right result, as long as you get to the right result in a way you understand. Okay, so that's another way you can do that. All right, let's put our radius on the front of this part. That's a 125 fillet. Right here. We'll hit OK. All right. That's all we need for the lathe. I mean, that's literally all we need for the lathe. Truthfully, we don't even technically need this part of it. Okay, that part of it's not doing anything for us. All we need is this upper profile. of the part to drive the toolpath. Okay. All right, we all good? I'm going to save real quick. That way if my autosave hasn't saved my drawing yet, I've got it. And let's go to our toolpath manager. Let's go to our machine tab. And now we're going to the lathe. Now you'll notice the lathe is a little easier. There's only one to choose from. That is our post for all of our lathes out here. So this is the same post we use for the 2-axis on the TM6s and 2-axis turning on the TM8s. And it also has the capability that whenever it's time to throw some live tooling toolpaths in there, this post drives those live tooling toolpaths too. So we'll select that. That's going to make that our active toolpath, or active machine group. Okay. Planes, let's go to there. And let's make sure we switch back to the top plane here. We want to be in the top plane. And I don't want you to be confused by the fact that it's showing an X and a Y here. The machine definition is going to control the fact that it's a Z X plane. Okay? The machine definition is going to control that. All right? If you don't like seeing that, you can leave the D plus Z plus active just so you see this nomin down here for your own peace of mind. It won't change the way the toolpath's at all, but I typically don't worry about it. Okay, I'm going up here and I'm leaving it in the top plane for my turning operations. Let's go into the properties of the machine group, because we're going to do stuff very similar to what we do on the mill. We'll call this our Lesson 1 lathe lecture part. Give it a comment for the setup. We're going to say set Z offset face apart, subtract 25 thousandths. Has anybody in here ever set up CNC lathe? No? So when we set the lathe up, we don't have a table. Okay, we don't have a table to set our tools off of. So the way we set the lathe is we'll put a piece of material in the turret, or in the spindle turret. In the spindle, we'll manually face the end of the part and establish a Z datum surface. Then we'll manually turn a little bit of the diameter of the part and establish an X datum surface. And then we touch all of our tools off the material to get a reference location for them and set all that up. It'll make more sense when you see it and we do it. But we basically establish our tool set off of some material that we put in the turret. It could be any size material to set all the tools, because everything's based off the X center line of the spindle. So when you set everything off an X, you're going to measure that material and you're going to tell it what the diameter is, and it asks for it. That way it knows what the tool tip is in reference to the center line of the spindle. And the Z is all based off of how far is the turret from the spindle face out away from it. So when you set the tools off in Z, that's basically what you're establishing there. How far is that turret out? So it'll make a lot more sense when we do it. Down here, we're going to use the default lathe inch tool library for the CamInstructor stuff. Okay, maybe on Thursday we're going to start building a tool library. I'm trying to get the list all together and stuff, and I need to go through and make sure. Last year we did it, and then I went on Seco's website and we spent more time trying to chase our tails because the website had changed. I need to go on and make sure all the stuff's where it used to be. And we can flow through it pretty easy. But probably on Thursday, we're going to build a tool library. So that'll be what we use for the stuff you actually machine. Okay. All right, but for the homework, same as last semester on the mill, use this default library. Tool settings. We'll just call this Program 1 since this is Lesson 1. Okay. We're going to tell it to, for the homework, you are going to assign tools sequentially for the CamInstructor stuff. That being said, I'm going to hand out, when we make this tool library, I'm going to hand out a list, and we're going to build the library that is what I call the VU standard lathe tool library. And when you use that, we're going to number the tools based on what number they're going to be in the machines in all of our lathes. It's a standard library, standard tool numbering. So when you come in here and you program your handle, your fastener, and anything else you might program for out here, you're not going to check that box because we're going to number them in the tool library based on what they are at the machine. That way, when you get to the machine, you post out your program, everything's apples to apples. If you accidentally check that box and it renumbers your tools, okay? If it renumbers your tools because you checked that box on something you're going to go run, you're not to change them in the machine. You're not to change the tool numbers at the machine. You need to come back to Mastercam and make it match what they are at the machine. That makes sense to everybody? We do that to help throughput, to get everybody through the lathe. If we go out there and start, you renumber your tools and then you go out there and you mess around and you change all the tool numbers around, then the next person has to go back through and change them all back. Okay? So if you have a tool number issue, when you post out your code, come in here. It's very simple. Just go select that tool, right click on it, edit tool, change the number to what it needs to be for out there. You're going to have a list. Literally, I'm going to hand you a list with the tools and the numbers so you know exactly what they're supposed to be for everything we're going to do out there. Okay? But for the CamInstructor stuff, have it assign them that way that they're not all the generic tool numbers. Like the first tool we're going to use, or maybe the second tool is like tool 44. You know, I just want to number it appropriately. So we'll turn on our modals, our overrides here. We'll come down here and for the lathe, we'll hit select. You can right click and tell it get from library for the material. I'm just going to pick aluminum 6061. So I just hit the select, right click here and get from library, and then pick your material out of your library there. One thing I always like to look at, because we're getting into the lathe land, and you know, inserts, we're doing some inserted cutters now because we're working on some people are getting the knuckles. You know, I like to, if you go to lathe edit here with that aluminum, see this ISO group? Remember what we were talking about the inserts on that 1-inch turbo mill the other day? How inserts have material grades? It is an industry standard material grade. So these letters that are on the Seco inserts, that's not a Seco thing, that's a industry-wide thing. Okay, those are ISO designations. So for non-ferrous, non-metallic, that is the N material grade. Oops, how did I do that? There we go. All right, stock setup. Now this page is going to look a little different. Now, if you didn't change your plane, I didn't change my plane back after I set my thing. So the stock plane, mine says D plus Z plus. If yours says that, you need to click on the plane button right here to select a new plane and just set that to top. Okay, make sure you set that to top. Okay. And basically the only reason it defaulted to that is because we activated our machine group while we were still in that other plane, so it grabbed it right away. So stock setup, page looks a little different, but we're going to set up our stock. We're using the right spindle. We're going to hit properties, or left spindle, sorry. Why I'm reading one and saying the other. Material here, this thing's 1.45, so let's say we're going to use 1 5/8 diameter for the OD. The length, yeah, we can just leave it 4 inches. We'll leave that 4. And then position along the Z-axis. Basically, it's saying how much do you have out in front of Z0 that needs to be faced off. Well, if we set it off the face and then we subtract 25 thou on our setup, we should have 25 thou, right? So we're going to tell that positive 25 thou here. When we do the facing toolpath, that'll make a little more sense, because that's going to be what lets the facing toolpath know here's how much you got to rough off and finish. Okay, that little number right there. So however much you're going to subtract, that's what you'd like to have tell it here is the positive amount sticking out from the z-axis. We're working in z negative. Everything we're doing, we drew to the left of the, the z. So we're working in z negative. And then we'll hit OK down here. You notice it just generated like a little gray dashed line that represents the stock. I think what you're going to find on the lathe that's kind of nice is as we create a toolpath, the little stock profile updates automatically. So you could actually see kind of in real time what the profile of your part's going to look like as we create each toolpath. The mill doesn't do that. So we've got our stock defined now. So the other thing we want to always define is our chuck jaws, because crashing into the part's one thing, but crashing into the chuck's another thing. Okay, you hit the part, you might throw it out of the spindle or something, you might break your insert. Turret or tool meeting chuck can do a lot of damage. So we want to make sure that we define that and tell it how much we're holding on to so that it can use the chuck jaws as a reference, that if we go too far back and it hits the chuck, it's going to tell us here, not when I'm out there and it starts sparking and making all kinds of crazy noise. Okay, so we're going to hit properties for the chuck jaws. Okay. We could go through and build a custom chuck jaw. I don't normally mess with it. I just leave them with the little step jaw like it is, because really the only thing I'm worried about is where's this leading edge at on the part, how far am I holding on to it so I don't turn too far back into it, my holder doesn't get into it whenever I come in to part something off. Our jaws are just regular rectangular jaws. They're about 1.5 inches width, and we could go through here and we could adjust this, but like I said, I don't normally mess with it. I go over to parameters right here. Clamping, we're going to clamp on the OD. Okay. I'm going to tell it to pick the position from stock here, which you notice when you click that, it automatically puts your diameter at 1.625. That's what we're grabbing hold of. And it wants to know how much are we gripping onto. So we made the stock 4 inches. We got to cut at least 2 inches back, plus we're going to go a little more because we're going to do a part off. So I'm going to tell it 1.5 inches here. So if I do 1.5 inches there, that means I have how much sticking out of the chuck of a 4-inch piece of stock? 2.5. So that should be good. We can go 2 inches, plus we're going to go about another 150 thou for the parting tool. We'll be good. We shouldn't have any collisions. If you check mark, make sure, the other thing I have happen sometimes, make sure you don't, if you click on properties for the tailstock, even if you don't do anything, if you just say, I'm not doing anything, it automatically defines a default tailstock, and then you'll see some collision issues. If your tailstock shows up here, you need to go back in your machine group properties into the stock setup and just hit delete here to delete the tailstock. Okay, just hit delete. We don't want it in the way. We'll tell it OK. If I zoom out, there you get an idea of what the stock setup looks like. Very good. All right. You ready? Okay. Toolpaths are simple, guys. It's a lathe. It's just, same concepts up here. We're going to use everything in the general tab, not down here in the can cycles. We don't have, our post is not set up to use can cycles. It does everything in longhand code. So we need to use the general toolpaths up here. These are for shops that have older lathes that don't have much memory on them. So they need to use the same can cycles like we wrote last year in the manual programming. Mastercam has the ability to post those out. Like you can build a special post for that to do those. Our post isn't set up for it. Okay, because we have plenty of memory, so you'll get a better result with longhand code, and you can kind of control the cut depths a little better with longhand code than you can with a CamCycle. CamCycle is just, it's going to be all straight and square, and it doesn't have any overlap built into it, just like what we did last semester, or last year. So you're working up here. Okay, these are the tool paths we're going to use. So let's start out. Let's face this part. Let's go ahead and we'll start out by facing it. For the tool, let's hit select library tool. And you want tool 1, which is your 80-degree right hand roughing tool. Okay, right here, this tool here, just pick it and tell it okay. All right. Now down here, you see this axis combination spindle origin? Click on that little button with me. Lathe upper left. What does that mean? Well, that means that turrets, upper turret, meaning the slant bed lathe, and the spindle's on the left. That's all that means. That's our orientation, that's our machine definition. Okay? That's what that is. We're not changing anything here, I just wanted to show it to you. We'll hit OK. Alright. Feed rates. Now, I did get asked this yesterday. Tool number, offset number. So on the lathe, when we program, if you remember, you don't use an M6. It's just tool number and the offset number, T0101. Station number. The station numbers will not always match where the tool's at. Like when we set the machines up out there, tool 1 will be in station 1, tool 2 will be in 2 and 3 and 3. But then when we get to like the drills, we have to start indexing them, meaning we have to space them out because they can't be right next to each other. If I've got my spot drill here and my drill right next to it, my drill's sticking out an extra 2 inches, and I come in to spot drill my part, and it's a little short part up in the chuck, well, my drill's right there next to it. Now my drill's running into my chuck. So you have to kind of give them some space and do that. The station number in Mastercam means nothing to what gets posted out to the machine, unless you're setting up a setup sheet that you're going to hand to a setup person. If that's the case, you want to make sure you set the station number to where you think that tool needs to go in the turret. What station does that tool need to be in? So that's on you, making sure that those get spaced accordingly. All right, you'll learn more about that out there. Feed rate, we'll rough at 10 thou per rev. We're also going to finish, so we'll do that at 3.5 thou per rev. We'll use a constant surface speed of 600. We'll just leave that. We'll use the same constant surface speed. Sometimes, well, let's do that. Finish spindle speed, we'll use a constant surface speed of 750. A lot of times we'll speed up that CSS for the finish. And then max spindle speed for the lathes out here is always going to be 1200 RPM. Why 1200? Because what are the feed rates on a lathe based on? Diameter, but are we on the lathe, like when you set up your feed rate out there, it's feed per rev, right? So the faster the spindle's spinning, the faster that part, the tool's feeding. The TM8s out there, the TM8s, I don't want to lie to you, but I'm pretty sure they've got a 4,000 RPM spindle. Okay. 4,800 RPM spindle on the TM8s. Okay. Little TM6s. I think they've got 2,500 RPM spindles. $1,090? That can't be right. That ain't right. What? That's a faster spindle than the... That can't be right. Unless I read this one wrong. Is that for the live tooling or is that for the actual spindle? We're going in. We're digging in deeper real quick. Come on. Go to the page. Seems crazy to me that the TM6 has a faster spindle than the TM8, but maybe it does. Anyhow, doesn't matter because we're going to set it at 1200. We're not trying to break any speed records here. We're just trying not to tear a bunch of stuff up while we learn. Okay. All right. Rough and finish face of workpiece. And we'll go over to the parameters. You notice, like on the mill, you remember how many linking pages there are you got to go through. The lathe, there's 2. Okay, now we get into some grooves and things like that. There's a few more, but for facing, it's not rocket science what we're doing, right? We're just facing the part. For the stock, or for the facing geometry, use stock. So basically that stock setup we did, kind of like on the mill how you can use the stock, we're telling it use the stock for the outer boundary so it knows there's 25 thousandths that needs faced off the front of the part, and we're facing it to Z0. We'll leave that. You can set up points and basically create like a boundary. If you think back to what we did when we would manually face stuff last year, that's what we did basically, right? We set up a boundary, and that's how it knew where that can cycle needed to machine all that material away. So you could set up 2 points and do a boundary, but I usually just use stock. The entry amount we'll leave at 100 thou. The rough step over, we'll leave that at 100 thou. Well, don't leave it at 100 thou. Let's say at 30 thou. 30 thou is your max facing depth of cut in here. Okay, you can try something. You can go heavier down the road, and it's all about the lathe is much more subjective than the mill. Okay, you know what I mean by that? Basically, the lathe is so much is dictated by how much is sticking out. You know, how much of the part's sticking out of the spindle. How much am I clamping onto? You know, how rigid's my setup can make a difference on how heavy of a cut can I take. If I've got a super good work holding situation and the part's not sticking way out super long, you know, I can go hog wild and remove a whole bunch of material pretty quick. But if I'm holding on to like a 1/4 inch of a 3-inch round part and it's sticking out 5 inches, probably don't want to go in there and put a bunch of tool pressure on it on the end of the part trying to face that off, because what's going to end up probably happening? It's going to pull it out of the spindle. So you got to be subjective with your decision making on the lathe. And when in doubt, if you're not sure and you don't know if taking a bigger cut's a good idea, what do you think you ought to do? Take the lighter cut. Okay, take the easy. It might take it another 1.5 minutes. If you're making 1 part, 2 parts even, it might take it another 1.5 minutes, but at least you're not taking the chance of crashing the part out of the spindle, tearing up your cutting tool, maybe tearing up your chuck jaws. Okay? You don't have to be aggressive until it's time to be aggressive. And that's not until you're going into a situation where I've got to make thousands of these parts, so it's time to start pushing things and trying to figure out how much can I take? How fast can I take it? What's my insert life going to be like? You know, that's where you get into those situations. That, not out here. Okay, we don't need to do that out here yet. All right. So 30 thou max depth cut. We got a finish step over. We'll tell it we want to do at least I don't know. I'd say at least 5 thou for the finish in aluminum. The overcut amount for the right here, how far past the center line. So when you face the part out there, you're facing it, and usually you're using your power feed. You're facing it, but you don't kick off the power feed until you know it's got past the center line, right? And that's a visual thing out there in the manual shop. Well, out here, we got to program that. So what I do is my overcut amount is whatever my tool nose radius is, okay, which is this particular tool has a 30-second tool nose radius. So I'm going to set my overcut amount to 30-second. That way I know that I'm not going to leave that little tip behind on the front of my part. Everything's static out here. Everything's calibrated and aligned. So tool post out there where you're adjusting your height and trying to get your tool heights right, out here you should never have to do that. If you have a tool that's not cutting on center, the machine's been crashed and has a turret out of alignment, it needs to be fixed, or the setup for the tool is not right. Meaning that I've had people that have put tools in the upside down, basically, and then they're like, well, I'll just turn the spindle the other way. Well, the gauge line of the tool is based on being in the turret the correct way, and it'll be close, but usually it's like 50 to 100 thou off, and then that leaves that little tit there, and then you look at it and you're like, oh, you got the tool upside down, and what they do is they put it in upside down, then they just turn the spindle on the opposite direction, but the gauge height's not the same. So we're going to go all through all that out there. We don't need any of this other stuff. We can leave, what we got here. We're going to face it right to 0, so we're not going to do any, for the facing, we're not going to do any stock to leave. Sound familiar? Kind of like when we face side 1 on the mill. Yeah, we take it right to 0. We're not going to cut it from the center line back. We're not going to come in and cut this way, so we don't want that. And we're not cutting across the center line. We couldn't even do that with this tool. Across the center line, you'd have to come in with like a boring bar, like an axial tool, and you could actually come to the front of the part and face it this way. We're not going to do that. And I don't have a great example of when you would want to do that or why. But that's what that little checkbox is for. Compensation type on the lathe is typically always going to be set to computer. So it's not like the mill quite as much, because at the lathe we can go in the tool wear page and we can still move the tool in X. We can still move it back in Z, even without a compensation call. The only time we need to use cutter comp wear is if we've got a critical angle or a critical radius where the tool nose radius offset needs to be used to comp it in. Okay, meaning that this part here, we're just treating it like that radius on the front's not super critical, so we're not going to use it. But that's when you'd want to use that, where you're using your tool nose radius comp at the machine to let it comp around radiuses and stuff. If it's just lengths and diameters, that's just straight adjustments. But when it's rolling that tool nose around a radius, if you're not getting that dimension where you want it, then that's where you need to turn on cutter comp. You're going to use wear typically. Control means that when you set up the tools in the control, you got to make sure you plug in the nose radiuses for all the tools if you use control. If you use wear, whatever the programmed nose radius is, Mastercam comps for it, and then you can just do your negative or positive adjustments from there, just like on the mill. Okay. All right, we're comping to the left. It's coming down the face. So you think about the tool travel, it's coming down the face. So as it's coming this direction, it's comping to the left. Okay, I know you're looking at that going, you're moving your hand to the right, but you got to think of the travel direction, which side it's on. It's going to be on the left-hand side. Hit OK. We don't need to adjust anything else there for the facing. You should see a roughing and a finish pass there. And you notice also that stock just updated. That 25 thou that was out here is no longer there. We just faced it off. Your little red arrow here, if you move that back up above that toolpath, it pops back in. If I move it down, it takes it out. You can literally move the red arrow up and down between your toolpaths to get a live look at what the preview is for that part of your program. Okay. All right, is everybody good? Wonderful. Okay. Let's rough this profile. So we're going to come up here. We're going to pick our roughing toolpath. On the lathe, it's going to default to partial chain because that's what you're going to select, because that's what you want. We don't want a full chain, and we don't want to select this thing going all the way around that part. Do I want to cut all the way around that profile that I just picked? No. So if you do that, it's going to go, okay, wait a second, this isn't going to end well. And if I generated this toolpath, it's going to have a collision in the warning because I selected the wrong geometry. No, we want partial. We pick for the partial, we pick the first, which is right here, this radius. And then we pick the last. So that's what it's telling us to do here. We pick the last, which is going to be right here. And that's what the chain should look like. So one more time. We pick this chain. Let's say I pick that and it's going that direction. I hit the R key and I reverse it at that point. Then I pick the last one. That's the lathe. That's how we chain on the lathe. First and the last. It grabs everything in between. Tell it OK. For the roughing, we're going to use the same tool. Over here, we're going to just bump up our spindle speed, our constant surface speed to 600. Set our max RPM to 1200. Those numbers, okay, I know I'm changing them manually right now, but when we build our tool library, we're going to build it with our aluminum tools and our steel tools. We're going to build two different turning libraries. Well, we're going to build two different turning libraries. We'll keep them separate, steel and aluminum. And basically the holders are the same, but the inserts are different on the lathe. So you'll have the same holders with the different insert for the different material grades. So coolant, so we want that on. And then down here we're going to say we're going to rough profile of workpiece. Okay. Rough parameters. I like to start up here, overlap. That's what I'm talking about in the can cycle, where a can cycle is just going to leave those steps in there and it'll have sharp ridges on like that radius and stuff, where this longhand will actually do a deal where it'll cut an overlap and it'll take those out while it's roughing. So when you do your finish pass, you get a smooth, you're not encountering any heavy parts of material anywhere. Okay, we're going to leave that just 10 thou overlap. Depth of cuts, I like equal steps. So an equal depth of cut all the way through the roughing, as close to whatever we set our max depth of cut to, and let's set that to 30 thou. All right, over here, entry amount, we're going to start 100 thou off the part. Exit amount, we're going to leave that alone because I actually do that. I typically do that in the lead in, lead out over there, so we'll just leave that at 0. But you could, if you want it to go further back past the end of the part, you could do that here, but I want to show you how to do that over in the lead in, lead out. So leave that at 0. We'll leave 10 thou for our finish pass on the faces and the walls. Okay, so on the diameters, we're leaving 10 thou. On the faces, we're leaving 10 thou. It should be good there. Cut direction, we're going, okay, you can kind of look at what we've got here for roughing. We're going from the right to left. at a 0 degree angle. Good there. Down here, stock recognition. Turn remaining stock on. What that'll do is that 25 thou that we've already faced off, it won't look at that as being there still. Okay, it'll generate the toolpath based on that 25 thou already being gone, which isn't a whole lot on this part, but there might be a time where you faced off a 1/4 inch. Well, then it's going to, if you don't turn on remaining stock, it's going to start out there like it's got to rough that off there still, because it's going to look at the stock as the boundary. So that's basically saying, hey, what's remaining? So it's like the read machine on the mill. It's looking at all the previous toolpaths and saying, okay, this stuff's done already. All I got left is this. Here we go. Lead in, lead out's the last thing we need to adjust. So the lead in vector is coming straight from the right to left, straight into the part. I'm good with that. We're not going to change anything on the lead in. It's going to have a 100 thou lead in. We're good with that. The lead out up here, when it leads away from the part, it's going to exit at a 45 degree angle away from the part, away from the chuck. I'm good with that. But I do want it to cut on back past the end of the part some extra, because we're going to part this off here in a second. So just like on the mill, there's an option to adjust the contour for the lead out, extend it, and let's do 150 thou. The parting tool, we're going to use the 1/8 inch wide in the default library. So basically we're going 25 extra thou for us to part this off. Tell it OK. And we'll hit OK here. And there's our toolpath. Everybody's look OK? All right. That's roughing. Okay, it's not, like I said, the lathes, you guys know what you're doing on a lathe. You're facing, you're roughing, you're finishing. And here we're going to part off too. So if everybody's looks good there, notice one thing. If you shut your toolpath off so you can see this a little better, just hide your toolpath. Notice, even though this toolpath comes, and it looks like it's coming in here to this sharp corner. Okay, it looks like it with the toolpath on, but if I shut it off, the stock preview shows that big radius there. Well, the blue lines are the theoretical perfect point of the insert. Okay, the blue lines are like, hey, here's where the leading edge in Z and the leading edge in X, here's where they're going to, the programmed position. But since the tool has a 30-second nose radius on it, this is all the further into that corner it can get. That's what it's actually going to be cutting. So this is the theoretical perfect point where this edge and this edge intersect. But since the radius is there, that's all the more we're getting cut. So if that was a situation, customer says, hey, that won't work, we got to get further into that corner. Okay, we got to get further in that corner. I've got a couple options. I could look and see if, like, my 80-degree tool, if there's an insert option with a smaller radius on the insert, or I could go to a sharper angle tool to come in there and get back in that corner further. The only time I switch tools is if there's a situation like that. If my 80-degree tool can do all the work and finish everything to the size it needs to, I don't want you to get to where you're looking at it, because in the default library it calls it a roughing tool, and it calls the 35-degree tool we're going to get a finishing tool. Don't look at them that way. 80-degree tool can finish a part just fine if it can get into all the areas it needs to. We're going to look at some stuff that has undercuts, kind of like what you see up here I've got drawn. So I might have a part. Here's my part. And then here I might have like an angle and it comes down and then maybe comes back out and does this kind of thing here. Well, there's a good chance that my 80-degree tool can't get down into this area. Okay, so what the tool will do is it'll get as close as it can without the leading edge of the tool colliding with anything, and it'll cut as far down in there as it can. So it might leave material down in here to that amount. Mastercam, when we set up the tool geometry, it's using that tool geometry to literally say this tool can get right here. This is all the more you can get with this tool. And if I've got that left behind, well, then I got to come in with either a 55-degree tool or an 80-degree or a 35-degree tool insert to be able to get down in those concave areas. But if I don't have something like that, I don't have to switch to the 35 or 55-degree tool. If it's all straight across and my 80-degree tool's got the right insert nose radius to cut everything, I'll rough and finish it with that same tool. No reason for an extra tool change. Okay. All right, so let's go ahead and finish this, and we are going to switch to the 35-degree tool so we can get further back into this corner here. So go to finish up here. For the chain, you want the same chain. I'm just going to click last right here. It should grab that last chain since I want the same one. If it didn't, just you can partial chain it. Start in the end. Hit OK. Select library tool. And we're going to pick this, what's T2121 in the default library, the 35-degree tool that has a 64th nose radius right there. We'll pick it and hit OK. All right. This is a finishing toolpath, so we're going to do 3.5 thou per rev. We'll set the constant surface speed to 750 and max RPM to 1200. Okay. We'll turn on coolant. And then we'll say finish profile of workpiece. Finish parameters. Finish step over, tell it 5 thou. We're just going to do one pass. Stock to leave. I typically on the lathe, you know, I don't leave a lot because I set my tools. When I set the tools, you're going to notice I set them kind of loose so that they will cut oversized. So whenever I'm setting off my tools and we touch them off out there, you're going to see I'm going to move them. I'm going to touch off and I'm going to move it a couple more thou from where my scale slides through to set them off, and that way it will cut everything big and let me bring the tools into the part. So I don't usually leave any stock here like I do on the mill. My lathe and mill techniques are a little different. Okay. Lead in, lead out. It's the only other thing we got to change. We're going to do the same thing to the lead out that we did on the roughing. So we go to lead out, and we're going to extend. Make sure you set it to extend the lead out by 150 thou. And we'll hit OK. There's the finish toolpath. You can tell here that got a lot closer in that corner. There was the roughing. There's the finishing. I wish there was a way they could make the mill do that to where you can just move your arrow and see that wireframe kind of stock update real quick. But, you know, that's just that. That's a mill lathe thing. Everybody's good? So far, what do you think about the lathe? Pretty tough, isn't it? Think so? The lathe, the programming side's not near as complicated as the tool side, and making sure you get the right tool and making sure you get all the right numbers and everything. There's so many lathe tools. There's a lot of mill tools too, but every insert holder literally has dozens of different insert grades with different geometries, chip breakers, so many wipers, all these different things that are on these different inserts that come into play. The lathe is one of those things where I lean on my tool rep a lot more than the mill. I'd say, here's what I'm working on, here's the project, here's the material, here's my work holding situation. Okay, what do I need? And they give you options. Here's what we've got that I feel like would work good for this. Let's do some test cuts. I'm working on a part right now that's a stainless part. It's about a 4-inch base. It's 1/2 inch thick on the base, and it's necked all the way down to 1 5/8 inches. That comes out 3.5 inches. It's got 3 undercuts on it. It's got some threads on the end. It's got some ID threads with an undercut in the ID too, and then it's got some live tooling holes that got to be drilled in the sides of the part. Seco guy's been doing all the test cuts for me on this project. Like, I was like, hey, can you come in and kind of tool this up? So he's literally been doing like the test cuts and bringing in tooling and getting everything tooled up for it. So that's where you lean on them. That's how they make their money. That's what they do full time. They pick the tools and help make things run efficiently and extend tool life. So, all right, last thing we're gonna do is part this off. So up here, there's a tool path called cutoff, and it says select the boundary point. So this is what you need to know. The boundary point needs to be the furthest out in X on the diameter and the furthest back you want to part it off. That's the point you need to pick. So for this part, it's this point right here, this corner. That's our cutoff point. Not the point down in the center part where you want to cut to. Okay. We're going to select the library tool. And this is probably the one that's the 44. Yep, it is. Right here, this 125 thou right hand groove part off tool. That's what you're going to pick. Tool 4444. Hit OK. I'm not going to mess with the feed rate or the spindle speed. I'm going to let it go slow. It's cut off. Cut off. You got to be real careful, especially in soft metals like aluminum. If you're doing a part off, you better have really good coolant flow, because it's easy for that part off tool to build up on the leading edge of the tool, and then it just melts its way through the part until it kills the tool holder. So you got to make sure you got really good coolant flow on a part off, especially in a soft metal. Max spindle speed, 1200. Definitely want coolant. Yeah.
Where was the boundary point?
Can you show him where the boundary point is? Good. We definitely want coolant on. And then we're going to say part off workpiece. Okay. You good? All right. Cutoff parameters. The entry amount, you're going to go 100 thou from the stock. Okay, that way it's recognizing the stock and where we've cut it to. The retract radius, I'm going to tell it to go 100 thou from the stock. Okay. The X tangent point, I want you to set that at 50 thou. Basically what it's going to do is it's going to part off all the way down to, it's a radius value, it's an X tangent value. So it's going to part it down to where there's a 100 thou piece still holding onto the part for us to break the part off. Okay. Back face stock, if you want any there, you could put some. Like if you're going to flip the part around and face off the other side and try to get a true dimension, you could put that there. I'm going to put 10 thou. Down here at the bottom, this is something that I do like. Radius to apply new setting. So let's tell it, hey, when you get to, let's say when you get to 125 radius, so a 1/4 inch, holding on to the part still, which should still hold it where it's not going all over the place. I want you to slow the spindle speed down to a set RPM of 200 RPM. That means it's going to throw in a G97 with an S200. It's constant 200 RPM from there on, that it's not going to be ramping up to that 1200. It'll get to 1200 before that, but it's going to slow it down there at that radius, basically so that when you get to your true part off, your part doesn't get to flinging around and get loose and go dinging all over the machine like a pinball. Okay, you're just slowing it down there. All right. We should be able to check mark out, and you should see that part off. And there you see the 100 thou that it's leaving there for that to hopefully leave it to where we can break it off. Now there's times where you run the first time and the part falls off on you, and you just go increase that radius a little bit. Okay, if you want to be able to break it off yourself. Or if you've got a parts catcher, you know, maybe you do want it to part all the way off and drop in the parts catcher, and that's another reason we slow that RPM down, because when it releases, you know, it might release when it's on the upcut, and if it's spinning too fast, that part goes this way, it doesn't just drop. But if you slow the RPM down, gravity's going to do its thing rather than the centrifugal force, and it'll fall into your parts catcher or into your bucket that you're catching your parts in. So, all right. What I'd like you to do now is select all these toolpaths, highlight them all, select the whole toolpath group, right click it, go to edit selected operations, and go to edit common parameters. These are two things I always want you to do on the lathe. First thing is, in case you didn't catch one of the max spindle speeds, always go to max spindle speed here and set that to 1200 for all your toolpaths. And then the other thing we always want to do is make sure that for all our toolpaths we have coolant set to turn on for all of them. Okay, those two things, those are every time you do a lathe program for out here. Select at the end when you feel like you're ready to go to the machine, select all your toolpaths, edit common parameters, set the max spindle speed, set the coolant. If you want to set your max spindle speed at 600, I don't care. You can slow it down more if you want, but don't go anything over 1200. Okay? All right. Now, just for fun, let's post this. With all of them selected, let's go to the G1 post selected operations. It should have the Herco TMM8 post. Tell it OK. I'll just put this in our, I'm going to put it in my generic library. You can put it in your thaw space if you want. Okay. There's our lathe code. So max G92 S1200, max spindle speed 1200, constant surface speed 600. There you can see it doing its thing, roughing the part. Go into tool 2, finishing the part. Constant surface speed 750. Yep. Tell it yes, sorry. Yeah, click yes on that. I forgot that.
Click the X.
Click
out of it and it'll show.
Yeah. Click yes and then X out of it, and then it should bring the code in. For some reason the post processor is not updated on the on those. It'll just tell it yes to update, X out of it, and then it should bring the code up. Good? Yeah, I don't know how the post processor for the lathe, for some reason it didn't update when we put the 2022 on there. So coming down here to the part off. So here, notice this, we're parting off. We get to X.25, G97, S200 M3. Spindle speed slows down to 200 RPM to go on down to the final part off. Okay, where it's going down to X.8. Didn't we set that to 50 thou? Should be 0.1. Not sure why I did that. But anyhow, there's the code. Okay. All right. I'm going to have to look at that and try to figure that out. You guys, what I want you to do now, repeat. On CamInstructor, you need to do lesson 1, exercise 1. Take everything we just did and do it to this part. Yeah.
Wasn't that tool we selected for the part off T4444?
Yeah.
Because when it posts out the code, it says TO303.
Yeah. Because we told it to assign new numbers. So it renumbered them. All right. So you've got to take the next, you got 30 minutes. Take the next 30 minutes to draw this part, program it, apply the toolpaths to it, exact same as what we just did. Okay? Turn on a little music for you guys.